A coin is biased. Question number 8. So probability of getting head is 2 over 3. Probability of getting tail is 1 over third. And question part A. This coin toss repeatedly. The first tail will occur on the sixth toss. The first toss head, second toss head, third toss head, fourth one head, fifth one head, and the sixth one is only tail. So we want to find the probability of H intersection H intersection H intersection H intersection H 1 2 3 4 5 and tail basically. This is going to be 2 over 3 times 2 over 3 2 over 3 2 over 3 2 over 3 times 1 over 3, that is 2 over 3 5 and just 1 over 3. So this value is going to be 32 over 729, which is 0.0439. And part B now, in first 8 tosses there will be exactly 2 tails. So first 8 tosses. So first toss, second, 3, 4, 5, 6, 7, 8. So those are the tosses. So we can get exactly 2 tails. So basically we can get this one and this one, and the all other are head. Or this one head, tail, tail, and head, 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 head. So likewise, we have set of opportunities like that. So tail, head, 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 choices. Lot of choices like that, few choices. So if we assume that x is the variable that count number of tails, not head, then n equal 8, p equal 1/3, and then this is follow binomial 8 1/3. So having two tails, so there are how many options there? 8c2 out of 8, 2 tails. So getting 1/3 2 and 2/3 6. So this value is factorial 8, factorial 2, factorial 6, 1/3 1 over 3 square times 2 6 over 3 6. So this value is going to be 0.273. So you can find this value from the computer calculator. This is just for your information. And now we know that getting 2 tail means getting 5 head. You can define the other way around as y equal number of heads. 2 tails exactly mean 5 head exactly. So then n equal 8, p equal 2/3. And so then y follow binomial 2/3, 8 2/3. So then 8c5, 2/3 5, and 1/3 uh, 2/3 6 and 1/3 2. So you can see both they are same. So here 1/3 is here. So if in terms of this is x count, so this is the binomial. If it is y count, so this is the binomial distribution. Question number 9, the hospital scenario. A patient come to the emergency department has to wait more than half an hour. The probability is 3 out of 10. 3 out of 10 people have to stay more than half an hour, so P is 3 out of 10. Then if we select 12 people, so n equal 12, then x we can define a variable number of patient more than half an hour. Then this variable follow binomial distribution, 12 examples with 3 out of 10, which is 0.3 p. So then 1 minus p is 0.6, p is 0.3. And the first question is none of them wait in more than half an hour. So probability of x is 0. So probability of x equal s is pcx px1 minus p n minus x. So then this is 12cx 0.3x, then 0.6 12 minus x. So px equals 0 is 12c0 0.30 0.6 12 minus 0, that is 12c0 is 1 times, this is 1 times 0.6 to the power sorry, this is 0.7 actually. 1 minus p is 0.7, so addition 1, so 0.7 to the power 12, 0.0138, 138. And part B, people, patient more than 2 will have to wait more than half an hour. So probability of more than 2 people have to wait greater than 2. It means probability of x greater than or equal to 1. Then this is equal 1 minus probability. Sorry, this is greater than or equal to 3. So we can't take 2, the possibility is 3. Then 1 minus probability of x less than or equal to 2. So 1 minus, when you go to cumulative distribution from the calculator, you can get this value, that is 0.2528, or from the page 205 from table. So table is faster than typing the numbers in the calculator. So this value is going to be 0.7472. Question number 10. State clearly a condition under which it is appropriate to assume that the random variable has a binomial distribution. This is a standard question. So part A, fixed number of independent trials to possible outcomes, success and failure, fixed probability, fixed probability of success, the trials are independent of each other. The outcome of any trial is independent from the outcome of any trial is independent from uh, any other trials. Just to revise you a bit, assume that if you put coins 3 times, first time, second time, third time, so 3 trials, so 3 trials has to be independent. At the same time, fixed probability. So if it's getting head, then it has to be half. This time it can't be different one, 3 out of 7 and 4 out of 8 for third time. It has to be fixed. That's why fixed probability, a fixed probability of success, fixed number of independent trial or fixed number of trials or independency here. Two possible outcomes, fixed probability of success. Outcomes is any trial are independent of E. Yes. Part B, uh, it is convincing team. Convincing team try to persuade customers. The persuading probability is 0.05. So probability of persuading is 0.05. Probability of persuade 0.05 when they go to a house, and find the probability that at least 2 success out of the first 10 houses. So n equal 10, at least 2. So we want to find so p is 0.05, 1 minus p is 0.95. Probability of at least 2 success. X is the variable number of success. Probability of x greater than 2, at least 2. So it means probability of x greater than or equal to 1. Greater than or equal to 3 from the number line. So this is 1, 2, 3. So, and this is 1 minus probability of x less than or equal to 2. So 1 minus we can Sorry, I think it is at least 2, so this is going to be equal to 2. Then this is simply, this is the answer. 1 minus probability x less than or equal to 1. So at least 2 mean including 2. Including 2. So 1 minus 0.9. From the table we can take this answer 0.0861. And part C of this question, calculate the smallest number of houses we must canvass so that the probability of his getting at least 0.9. So we'll define variable y is number of houses, uh, number of success, and y follow binomial. Now we don't know n, but still the probability 0.05. So probability of y, at least one success exceeds 0.99. The probability of one greater than or equal to 1 should exceed. It means minimum 0.99 or more than that. So when you draw a number line, so 1 is here, so 0 is here, so 1 or equal, this area has to be greater than 0.99, more than 99. It means this will imply that probability of y, then the remaining one, y equals 0, has to be less than 1 minus 0.99. So probability of y equal 0 is less than 0.01. Now what is the probability of getting y equals 0? So probability of getting y equal y is ncy py 1 minus p n minus y. Now n is n and y is 0.5, so this is probability of y equal y equal ncy p is 0.05y and 1 minus, this is 0.95, 1 minus and 9 n minus y. Now y equals 0 we need. So probability of y equals 0 is nc 0, 0.050 and 0.95 n minus 0. So now this is nc0 is 1. It doesn't matter whatever the number, 0 is 1. And 0.05 to the power is 1. And this is 0.925 n. Now this is 0.95 to the power n has to be less than 0.01. So 0.95 to the power n less than 0.01. So log 10 base 0.95 to the power n equal log 10 base 0.01. So then this will become n log 10 0.95 is log 10 to the power 0.01. So then n equal log 10 to the power 0.01 divided by log 10 to the power 0.95. So this value is 89.78 approximately. Then n has to be, so It, greater than, it means 90, 91, 92, likewise up to it goes to the infinity. But okay, it has to be finite number, so let's say like that. So the minimum number we can take n equal 90. So if you take 91, 92, definitely this probability is less than 0.01. So the smallest possible value is 90. 89.7, now round up to 90. The previous sum, it was in 9, but it has to be 10. 10, and now this one is number 11. And a completely unprepared student is given a true false type test questions and find the probability that the student get the answer correct. So it's true and false, two options. So the probability of getting true is half, and probability of getting false is also half. Now n is 10 and x is a number of correct answers. So x follow binomial 10 half, and so probability of question, all right, probability of x equal 10 is, okay, x is pcx px1 minus p n minus x. So this is px equal x is ncx, sorry, n is 10cx, p is half a x, this is 1 minus p is also half a n minus x. Then probability of x equal 10 is 10c10, so half a 10, uh, then half a 10 minus 10, so this is 1 half a 10 times this is going to be 1 again, 10 minus 10 is 0, so this is half a 10. 0.009 approximately. Part B, find the probability that a student passes the find the probability that a student to pass the test he has to take 8 or more correct answers. So probability of x greater than or equal to 8, it means 1 minus probability x less than or equal to 7. So this is 1 minus from table this value is 0.9453 and this is 0.0547. Question number 12, it is a bias die. Y is twice likely to appear as any other number. So 1, 2, 3, 4, 5, 6. Let's say this is x probability of getting p x equal is this x. I'll change this one to a 2a and a. So summation of p x equal x has to be 1. So 1, 2, 3, 4, 5 and 7, a equal 1, a equal 1 over 7. So getting 5 is 2 over 7. Now question number A, find the probability. The first 5 will occur on with the sixth row. Uh, First 5 will occur in sixth row, not in first row, not in second, not in third, not in fourth, not in fifth. Only sixth is the fifth one. So getting probability of other numbers is 1 over 6. So this is, let's say, P. Probability are defined for the binomial. So it is CCP is 2 over 7, and 1 minus P is 5 over 7, and Y is the variable number of 5 counting, and then yes, getting this is equal to n, probability of n. So this is 1 over 5, 1 over 5, and sorry, 5 over 7, 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 and 2 over 7. That is 5 over 7 to the power 5 and 2 over 7 to the power 1. So this answer is 0.0531 approximately. And part B, in the first 8 rows, there will be exactly 3 5s. Uh, First 8 rows, so n equal 8. Now y equal y follow binomial 8 2 over 7. Then probability of y equal y is PCY, NCY, PX 1 minus P n minus x. So n equal 8 now. 8CY, P is 2 over 7 x, and 1 minus P is 5 over 7, 8 minus x. So now I need probability of y equal 3, then 8C3, 2 over 7, 3, and 5 over 7, 8 minus 3. So that is 8, 3, 2 over 7, 3, and 5 over 7, 5. So that value has to be 0.24 to 6 approximately. Question number 13. A manufacturer produces large number of quantity of plastic jars, and 15% of jars are green out of that. So part A, define a way suitable distribution. So we can get X is a number of green jars, and n equal 10, P is given 0.15, 15% means 0.15, and 1 minus P is 0.85, and so X follow binomial 10, 0.15. And part B, find the probability at least 5 green chairs in the sample. So probability of x greater than or equal to 5, which is 1 minus probability x less than or equal to 4. Uh, this value we can get from the table, so that is going to be 0.9901, which is 0.0099. And part C, find the probability that exactly 2 green chairs in the sample. So probability of exactly 2 green chairs you can calculate from the calculator or from the cumulative distribution. Probability of x greater than 2 minus probability of less than or equal to 1, 0.8202 minus 0.5443. So this is 0.2759. Question number 14. The bag contains large number of beads, of which 45% are yellow. A random sample of 20. So we have to write the distribution. X is number of yellow beads, and n equal 20, and p equal 45%, which is 0.45. Then 1 minus p is going to be 0.55. X follow binomial 20, 0.45. And part A, define a distribution. Part B, um, part A, fewer than 12 yellow beads. So probability of x less than or less than 12. Fewer than 12, it means probability of x less than or equal to 11. So we will can get this answer from the table straight, 0.8692. And part B, exactly 12. So probability of x equal 12. So probability of x less than or equal to 12 minus probability of x less than or equal to 11. So that is 0.9420, and this is the one, 0.8692, and answer is going to be 0.0728. Question number 15. The archer hits the bull's eyes with the probability of 0.06, or probability of p equals 0.6. 1 minus p is 0.4. Uh, 20 arrows at a time. Find the probability that she hit with at least 50% of the arrows. It means 20 out of 50% mean it is 10 arrows. So x is the number of successful arrows. Then x follow binomial 20, 0.06. Then probability of x greater than or equal to 10 is probability of 1 minus probability of x less than or equal to 9. So from the calculator you can get this value 0.1275, which is 0.8725. Part B says you 12 set of arrows. Find the probability that so now there's a arrows 50%, at least 50% of arrows that which have the capability of 0.8725 of accuracy now. So now the probability is 0.8725, and this is just an adjective. So 1 minus p is, it's going to be 1275. So y is the number of success, and n equal 12 now. So y follow binomial 12 0.8725. Now we need to find probability of y equal 7. It means 12 C7 0.725 7 times 0.1275. So this is going to be 0.010327, that is 0, 3. And from this one now find the probability that say it with at least error. So at least 50% of error. So this is the capability of this arrow hitting 0.925, fewer than 6. So part C, probability of y less than 6. It means probability of y less than or equal to 5. So we can calculate from the calculator. Then this value should be 0.002407.